Okay, so let's say we want to find the equation of the tangent line of the following function, square root of x, at x equals to 9. And then we want to use that to estimate square root of 10. So let's not worry about this one for a moment. Let's just focus on finding the equation of the tangent line for the function at x equals to 9. So to find the tangent line, I'm going to write down the steps right here. So the first thing you do is you want to find the slope. And to find the slope, what you're going to do is you're going to find the derivative at whatever point you need. Now in this case, my a that I'm writing down here, that's going to be 9. So remember that the derivative at a point gives you the slope of the tangent line. And so here, since I'm looking for the slope of the tangent line of this function at 9, that means that I'm going to find the derivative at 9. Okay, now before I actually do that, let me, I want to draw a picture. Let me draw a picture right here. Because having a visual is important. So let's say I've got the function here, square root of x. So I've got a rough picture. So that's square root of x. And then let's just say that 9 is right here. So of course, at 9, the y value would be square root of 9, which is 3. Okay, so what I'm looking for is the equation of this line, the tangent line right here. Let me draw that. So that's the equation of this line that I'm looking for. Okay, so now I'm going to find, so step 1, find the slope. So to find the slope or the derivative at 9, I need to find first the actual derivative. So the derivative of square root of x, I've done this one a couple times now. This is just 1 over 2 square root of x by using the power rule. Okay, so then the slope, I'm going to call it m. That's the slope, the letter for the slope, you know, y equals mx plus b, is equal to f prime at 9 for the reasons we just talked about over here. And so this is equal to 1 over 2 times the square root of 9, which is 1 over 6. So this guy right here, this is the slope. Okay, now step 2 is going to be to find the y-intercept. Now there's a couple ways to do this. You can either use the equation y minus y1 equals to m times x minus x1. Now this isn't really my preferred way. My preferred way is actually to just use the general slope-intercept form of a line, y equals mx plus b. Now that's how I like to do it. If you don't want to do it that way, that's fine. But that's how I'm always going to do it. So I've got y equals mx plus b. I know that m is equal to 1/6. I know that x is equal to 9, because that's my x value. And then my y value is equal to 3. Now, if the y value isn't given, usually it isn't, you would just have to find it by plugging in the x value into your function, which we already did over here mentally, and we got 3. Okay, so we've got that. So then what I have is 3 is equal to 1/6 times 9 plus b. Now 1/6 times 9, well, I can just simplify into 3 over 2, so 3 halves. So then what I have is that b is equal to 3, and then if I move that 3 halves over, minus 3 halves. So that means that b is going to have to equal to 3/2 itself. Okay, so then my tangent line, let me erase this real quick. Then my tangent line is simply going to be y equals to my slope, which is up here, 1/6 x, and then plus my y-intercept, which is right here, 3/2. Okay, so this is my tangent line. So this right here, 1/6 x plus 3/2, is the equation of this rough kind of line that I sort of drew right here. And then the question is, well, how do I estimate square root of 10? Well, square root of 10, you'll notice, is, so if 10 is right here, then square root of 10 is going to be right around there. Aha! But notice, this is key, that my tangent line at 10 is very, very close to square root of 10, which is down here. So this little orangey guy is very close to this blue guy, which is on my tangent line. And so if I plug in 10 into, instead of plugging it into the square root, if I plug it into my tangent line, which is right here, if I plug in 10, what I should get is a number that's very close to the actual value. So let's try that, and then we'll test. So let's say, so what we're saying is that the square root of 10 is about approximately 1/6 times 10 plus 3/2. Okay, so if I reduce these guys, this breaks down into 3 and 5. So this is 5/3 plus 3/2, which is equal to 19/6. Now if I punch that into my handy dandy calculator, what I get is 3.166666666666667. Okay. Now notice, this is just kind of something to note, that if you punch in the square root of 10 into your calculator, if you punch this guy into your calculator, you get 3.162277766. Now, my question to you is, how close are these? Well, I think it's pretty obvious that they are pretty close indeed. Now, this is actually a whole entire topic amongst itself that we are going to see later on. This is called linear approximations, but I thought I would just give you a taste of one of the ways we use tangent lines.